Hello, everyone. Welcome to this Git and GitHub workshop. So my name is Louis-Justin. I'm in Katia Bertoldi's group, and today I will be presenting. But I have to thank multiple people, Giovanni Bordiga, who is on Zoom, who made the slides, Eder, Medina, and Florent, Pollet, who also will be here today to help you on your computers. So first of all, a few slides to explain why Git, why GitHub, and why we think that this can be useful to your work. So a little plan of the presentation. The first hour and maybe a bit more will be mostly about Git, which is a command line tune. And then the second part, which is the time we will have left, will be on GitHub because it's a bit easier. And so let's get started. So what is Git? Git is a command line utility, as I will show you later, which is used to track the different versions of text files. So it has been created a few years ago by Linus Torvalds, who is also famous for the Linux kernel. And so the main principle of Git is that you are going to make some changes to your files, and then you are going to, when you're happy with what you have, you are going to commit them to the history of the project. And then as time advances, you will have a tree of your commits, and you will be able to go up and down in this tree, representing the history of the changes you have made. So we are going to learn all of this in this presentation. It seems to be very complicated, but if you have a mental model of how it works, it becomes quite easy, in fact. So for your files in Git are living in different areas. The first one is on your computer, the one which exists without Git, which is called the workspace. So you have just a folder, and you have some files in it that you are currently modifying. And then when you add Git on top, you have this structure is here, and I'm going to explain it. So where the commits and the recorded history of your file live is called, so it's your local repository. So it's stored in a special way by Git, and it's optimized for Git for text files. So it's compressed and takes little space while preserving the whole history of your project. You can push, it's called push, this local repository to a remote repository, and that will be, for example, hosted on GitHub, and we'll talk about that later. And this will, for example, allow you to share your work with other people. And another thing, which is a concept in Git and other version control systems, is called the index. And it may be a bit complicated to understand, but it's really a crucial part of how Git works. So let's say I'm going to show you all of that with a working example later, and that you can do on your computer. But let's say that you have some files and you have some changes, and some of them you are happy with them. It makes, for example, a feature on your project. And some of them are a work in progress, and you don't want to record that in the permanent history of your project. So what you are going to do is selectively add with the git add command. You're going to selectively add some files which are of interest to you to the index. And once you have everything that you want in the index, you can do a git commit, where the content of the index will be permanently recorded in the tree history of your repository. And the files that you did not select, the changes are still here, but they are not permanently recorded. You will have to do a git commit for that. And of course, the fact that Git is incredibly powerful is due that to all of these commands that you can see over there, which can be used to go back in time. So for example, you added a feature which is maybe not relevant anymore, or which has a bug, and you want to go back in time. And you can do that quite easily with Git. You can rewrite history and do something really clean and manage projects with one people, just you, or hundreds of people. And there will be also some notions about, so you can see it's a tree structure about branching and merging, but I think we will do that. We will do that interactively. And so this graph is interesting because it shows you how Git work along with a remote server. So as you can see, so we have multiple people over there. I'm going to focus on just one. This is you are gray, and you are working on your files. And sometimes you have some features that you like, and you commit them to your local repository. And then you have on the server somewhere, you have a remote repository that is used to host a Git folder. So this one will be shared between a lot of people, but it's working separately from yours. So you can work as long as you want with just that. And sometimes you might want to publish the work that you have done using, we will say that later, a Git push command, and it will send them on the remote repository. And this is useful because the other people, the blue and the red people, can then see your changes and pull them into their local copy of the repository. So we say it's decentralized because everyone has its own working copy, which is sufficient for the project, but they can access a remote copy, which is shared by everybody. And as you will see, this is a very efficient way of working together. Yeah, finally, we sent you the link, so you have some very useful link that you can refer to after this talk. And yeah, that's all. So now I want you to take your computers and let's begin. So what I'm going to do, as you can see, I'm on Windows, but it will be the same principle will apply to Mac and Linux. And so this is my home folder, and I'm just going to, first of all, create a bash instance. So I'm going to explain everything, and as if you didn't know at all what I'm going to talk about. It will be maybe a bit quick, but you can go back to, it's recorded, so you can go back to that later. So as you can see, I just, yeah, shouldn't have clicked on that. Come on. Okay, so I just right click on there and open Git bash. So I already have two of them, so I'm going to close one. This is bash. I think you all have installed this if you read your emails before. Bash is a shell. So this one is in Windows. Windows does have one which is called CMD, which is a bit less useful than Git bash. But they are all the same. There exists multiple types of shell, like the DSH, for example. The principle is that this gives you a command line interface to the internals of your computer, and this can be used to do everything. In fact, you can control an entire computer system. Not much on Windows, but on Windows Server you can, but mostly on Linux, it's very easy. You can do everything inside your shell. So for this, we are going to use Git bash because it looks like a bit the Linux shell. So I'm going to put that in full screen. And so first of all, this will go along with the talk. I'm going to show you a few very useful Unix and Linux commands to work with your computer. So the first one that I'm going to do is called ls. And they have short names usually, especially the older ones. So I think this one is maybe 40 years old. So they used to have very short name, but there are only a few useful commands, so you will be used to them. The first one is used to list the files. So I typed ls. So as you can see, this is the name, my username, the name of my computer. This says that I am on the, so this is Linux for Windows. And this is the folder where I am. So this is my home repository, which is the user folder. And I'm in documents because I'm in Windows and it's Eder. Hello. And you have this little dollar symbol, which is the command prompt, which says, hello, welcome to the shell. You can now start to input some commands. So if I just do enter, you can see that everything reappears and there is this command prompt. When you go online, sometimes you have, you can type this bash command and underneath you have the bash command, and often you have the little dollar symbol, which indicates you are in bash. So the first command that I'm going to use is ls, which is used to list the files in your directory. So I tap ls and then press return or enter, as you might call it. And as you can see, I have a lot of files in this repository. And as you can see, it matches what the Windows Explorer shows. So another file that I can do, another thing that I can do that I'm going to do for this presentation is to make a directory. And this one is a bit more intuitive, which is mk to make dir. Mk dir in one word. I pressed, I have to add a name. So I'm going to say Git presentation. One thing that you will notice is that I'm not using any spaces in that name because it will make working with this more complicated. As you can see, some of them in my folder have spaces and you have to put them into quotes and it's not very practical. So I just make something when underscores. I press enter and nothing happens. One frustrating thing about Unix shell is that most often when the command works, it returns nothing. And if you have return, it's that mostly there have been an error. But if I do ls again, you can see that the Git presentation folder appeared. So now I'm going to do another command, which is called cd, which stands for change directory. And so cd, and then the Git presentation folder. And here I could type the whole name, but I'm not going to because I'm lazy. So I'm just going to type Git and tab. And as you can see, it completes automatically and I can do enter. And now I am in the good folder. Okay, so I can do clear to clean up the shell. So again, I'm going to do ls. And as you can see, I have nothing in this directory. Another command which is useful is ls-l, which shows you a bit more information, but as you can see, there's nothing. So what I'm going to do is also in parallel, you should have maybe installed VS Code. And most of you, I'm going to show you all the commands into the command line because it allows you to have a real deep understanding of what you're doing. But most of the time when I do work with Git, I work with the graphical user interface in VS Code. So I'm going to show you that along for your more practical work. So I'm going to go into the right folder. And as you can see, it's empty. And I'm going to do right click and open with code. So it does not take too long time. And here I am. First of all, I'm going to let's say you have a repository which has already some files and you want to pass it to Git. I'm going to create a file. I'm going to do it in the command line because I assume you know how to do it in VS Code. It would be just new file. So if I go back to that, there are a lot of ways that I can do that, but one could be open it in a text editor. So I'm going to type, for example, nano. Nano is a text editor in the Linux shell, which lives in the shell. So it does not open a graphical user interface. And I'm going to name it script.py because it will be a Python file. And so as you can see, the script.py file doesn't exist. So Nano will just create it. Okay, here we are. So we are in GNU Nano. So it's a very old text editor. So this one is quite intuitive because you have all the different the different commands. So the hat is for control everywhere. So it's very intuitive. And I'm just going to say a little print, hello Harvard in it. Very well. And to save it, I just type Control S, I believe. So route from line, I am in script.py, and I can exit with Control X. So maybe you have started doing all of that in your computers, and it would be good if you can follow along. And don't hesitate to interrupt me or ask any question to Florent and Eder, who have over there, can help you. So if I redo that, redo ls in my repository, I can see that now I have a script.py in my repository. And now I've been speaking for at least 10 minutes and we haven't touched Git at all. So now it's the start of the real Git talk. Git needs to work on the repository, but it doesn't work out of the box. You have to say, hello, this will be a Git repository, and that is done with the git init command. So Git is a command line tool, which means that for every Git command that you want to do, you have to start with Git and then the name of the command. So most often with Linux commands, you can do -h, and this will prompt you the help of the command. So I can type that. And I have a huge help, which is outputted. So as you can see, if I go up, you say usage Git, and you have a lot of options. So this says, for example, this is what I just did, -h, which show you the help. So this help, you can do -v, which will show you the Git version, and a lot of things. And underneath, as you can see, there are a few common Git commands which are listed. So it's useful to have a quick reminder. So for example, git clone, git init, you have a lot of them. And the one that we're going to use is git init. And as you can see, it says create an empty Git repository or reinitialize an existing one. And so this will be useful if you have an empty Git repository. So as you can see, I have the $ prompt which came back, and I'm going to do git init. And this one outputs one line. We are very lucky this time. It says initialize empty Git repository in the folder that I am in. So you can see documents, Git presentation. And now if I do ls, nothing happened, because Git uses a hidden folder which you can have over there. So you have to do like show the masked elements and also the extensions of the files. And as you can see, it's over there. You have a .git file which just appeared. And I'm going to click on it just once. It's a folder. You will never do that again because it's a hidden folder. You don't have to, you must not touch it in order to forget to work properly. Everything is hidden in here. And so you have different things. And this folder will store the history of your folder. And if I go back to this, I'm just going to do a magic command, which is ls-l-a, and A stands for all. So it will also show the hidden files. And as you can see, a few of them appeared. So you have the script.py file that we worked with before, that we created a few times ago. So you can see 3 minutes ago, the .git folder that has just been created, and two special folders which are in Unix, which is the dot folder, which in fact indicates that you are in these folders. So if I do, for example, cd dot, it will do nothing because it means change to the directory, this directory, so it does nothing. And there is also the dot directory, which is the one above. So if I do cd dot, it will go in documents, which is the parent folder. And another command which is useful is cd minus or cd dash, which goes back to the previous repository you were in. Okay, so now we have a repository and one file But as you can see, we did nothing to say to Git, take this file into account. And a very useful command is git status. And as you can guess, it will prompt you the status of the Git repository. So if I tap return, I have a lot of information which appeared over them. And as you can't really see the life of my repo, so I can do.
Well, maybe now we kind of ask the audience, do you guys understand what it is doing, what it's used for, does it figure out position? Is it kind of clear? Yeah. Forward. So this go into one set summary of how I think of it as a way of not having the same file on a computer. So there will be 1, 2, 3 files, final, something that always comes up when you're tinkering. So if you're doing it, you're just going to be working on file changes that you can easily go back to from the start, right? So right now, what we're doing is setting up all the scaffolding to be able to modify this file later so that we can then edit it back to it. So hopefully that's kind of the high level overview.
Yeah, thank you for adding that. Yeah, it's all you to effectively have only one file, and the history is in Git and not in the multiple files, which can be not very practical, especially when you are working with multiple people. So to come back to this Git status command, we have unbranch master, which I will explain the concept of branches a bit later, which also you can see here on this little between parentheses. We have no commits yet, which means that we haven't committed anything in the recorded history of the database. And we have untracked files. So this means that the following files are not taken into account by Git yet. And I have a list of files which contain only one file yet, which is in red, and it's our script.py file. And they even add a hint which says use git add the name of the file to include in what will be committed. So this is quite nice of them. And we have also nothing added to commit, but we have some untracked files. So a lot of infos, and it's always useful if you are a bit lost in your Git, what you are doing. You just type a Git status and you can immediately see what you are doing, where are the untracked files, the index, and everything. So what I'm going to do first, and maybe for that I can go back to this graph, is I have a script.py file, which for now it lives in the workspace. And I'm going to do a git add command, which will add it to the index, which will be a pile of files that will be committed. And then it's pretty straightforward, as I have only one file. I will add it to the local repository using a git commit. So let's do this. So I'm just going to follow it, what it says, and you can do this along and say if you have any problem. So as always, I tap my git command and then the git subcommand, which is this time git add. And then I want to append the name of the file that I'm going to add to the repository. And I'm not very lazy. I'm going to just tab, and it knows about it automatically because there is only one file to be committed. And so GitHub script.py will say add it to the index. Yeah, so this little one is a little warning, but you don't have to worry about it. But it's really, I mean, it's a remnant of history because I'm working on Windows. Don't worry about it. Yes.
Oh,
that's normal because it's the line ending of the file. So I think if I do, it's the line ending of the files. On each line of on Windows, it's a carriage return and a line feed, and on Linux it's only line feed. It goes back to literally the typewriters. So it's a remnant of history that will just stay like this for backwards compatibility, but you don't have to worry about it. And so now, but theoretically, you have no real output of this command, and I can just say a git status again. And as you can see now, we have some green, which is good. We still have no commits. We are on branch master, but there is now some changes to be committed, which is a new file called script.py, and I can remove it from the index. One thing that I want you to do before committing it is showing you all of that in the VS Code file. So as you can see, if I go back, can I? Yeah, I can do that. As you can see, I am in the Git presentation folder over here, and I can see that I have a script.py. And if I go over there to the source control panel in VS Code, I can click on it, and it's a bit too big. Yeah, I now have stage changes, and this is for the index, and I have the name of my file and a little A, which stands for added to the index. So it's a new file. And with VS Code, as you can see, and I will explain that to you later, but it's very intuitive. I can add files with simple buttons and then commit everything. But for now, I'm going to commit it in the shell. So for that, I have an index, and I'm going to say, okay, take everything you have in the index, bundle it, compress it internally. I don't really care about that. It's just internal to Git, and save it in the history, the tree history of the folder. And for that, I'm going to do a git commit. And now I have multiple options. I can do just git commit, or I could add a message. For the first one, because I think you're going to run into some troubles, I'm going to do just git commit and see what happens. So maybe you could do that along. So as you can see, it opened a text editor for me, which is Sublime Text, which is a very good text editor. And so it says a lot of things, listen to the commit message, and these are all commands. And I can say, for example, this will be a message that will be shown in the history of your file forever, more or less. You can modify it afterwards, but usually you don't. And this is really interesting about it because you can use it for 20 years. And you have some repositories start back to, for example, 1996, which were converting to Git later on, and you have still the messages input by the people working on it 25 years ago, which is really impressive.
Quickly, can everyone get this screen? Because sometimes you get a different screen. That's another screen.
Yeah.
This is Sublime. This is together. Configure. Is anyone seeing something that is scared?
Yeah, maybe if you haven't changed anything, you have something. You have the same text, but still in your shell. Do someone have something like this? Most often by default it's Vim. So I think I can show maybe on the screen over there how to edit a Vim file very quickly. Who? Is it on Vim? Ah, yeah. Yeah, one thing that you may have, thank you, Florent, is that you may have to configure, guys, you may have to configure, if it's the first time you are using it, something about Git, which is you can do like it's git config. It should be global. Yeah, git config global, and it prompts you to say the user.name, which will be so your name, like this, and you press enter, and then I think it's user dot after that it's user dot email that you want to add. So you can add these options, and it will ask you, because Git also, along with the file, it will store hash like a blockchain. In fact, it will start a hash of the file, and along with your name and your email to track who did the change. So I think you have to, if it's the first time.
Yeah, you figured before, you'll do it configuring later, but obviously everyone's set on the sender, that some of you might not know how it works or what's going on. And so at the end of the PowerPoint, the two ends that the least included, the most are the help, PowerPoint. And that's manual.
It's Vim.
Okay, so Vim,
No, it's okay because it's you are already editing.
but then how do you save it?
Control S.
Okay.
And the quit is written, it's Control X. So it's, but
Maybe-
Vim is frightening. So maybe one of you have, if you didn't change the Git bash when you installed it, you have Vim, which open with the same message over there. And you have to edit it, and you're stuck because it's Vim and you don't know how to do that. So I open the script.py file that you recognize from earlier on. And as you can see, so I will be typing, for example, I want to type, for example, I'm doing return. And as you can see, it does nothing. I want to type, for example, hello, and it does some bizarre things. So Vim, I'm not going to do a Vim tutorial over there. Do we have a third hour to do a Vim tutorial? But very quickly, Vim has multiple modes, and the one that it by default is the command mode, where you can type some commands, for example, with a colon and then some command. But to go into an editing mode, you have to type, for example, I. And then I'm in the insert mode that you can see on the bottom of the screen over there. And I can go and just edit normally.
And then, if you escape a lot and then type I.
Yeah.
Because then you might be in a different mode. So I will get you into this editing mode, this insert mode.
Exactly.
Escape again.
So if I do escape, you know, the insert disappears, and if I type something, nothing happens.
Okay. Useful are.
So to save, you might want to escape, to go back into the command mode, then do a colon and then a W, which stands for write. And so if I do that, I can go back to the Visual Studio Code, and as you can see, the file has been changed on Vim. Very nice. And to quit the file, I can do double escape and Q over there. And this will edit your file and save it. So now, if I show the file with, for example, cat, which stands for, I don't know, you can see that it has been modified on Vim. Okay, so I think you either have a good a visual text editor which appeared or Vim, but now you can just add a new commit message. I'm going to revert that. We can keep it. Okay, so now I'm still doing my commit, and I'm going to add a commit message. And the point I was making is that this is going to stay in the recorded history of your project for quite a long time. So you have to make sure that you input the meaningful commit message. And you can say, I don't really care because I know what I'm dealing with. It's my files. First of all, you may be working with other people and they might want to know what you are doing. And second of all, most often than not, even with most often with code, the main person that will be confused by the thing you are doing now will be you in the future. So you might want to re-enter meaningful commit messages. So this one is difficult to be meaningful about because it's the first one we add the script.py. So I'm just going to do initial commit and then the name of the file, which is not really useful, but I could say this is a script to do something. Another thing is that you want the first line to be quite small. So here I have 27 characters. You want to cap this to 72 to be able to show it clearly in GitHub and in the log. So I'm going to show you all of that later. I'm going to save it and then just close the file. And if I go back to the good shell, you can see that we have a Git commit, initial commit, one file change, one insertion, which is one line changed, and create a script.py. So now if I do a Git status, yeah, of course it has been modified since. Yeah, if I do a Git status, it froze. Yeah, sometimes the bash froze. It freezes, so it's not. Don't worry about that. I can do a Git status again, and I have working pre-clean, which is nice because it says you have some committed changes, but it's in the history, and you don't have any modified file on top of that. Okay, is it clear for everyone until this point? Do you have any questions? Yeah, I'm going to explain that with another command. So one thing that you might want to do is see the history of your changes. And for that, I'm going to use the git log command. And you have a lot of information. This is so it says it's a commit. You have the hash of the commit, which is unique. You have head, which I will explain later. Master, which is the name of the branch. The author, as you can see, it has my name and my mail address on it. The precise date of the commit. So as you can see, it was made already 10 minutes ago, the UTC times and everything. And then what you just input. And this will be also shown on GitHub. So if I go a quick preview, if I go on my GitHub profile, and I go to a random repository over there. Okay, as you can see, there is my name over there. So it's the GitHub interface that I will explain in 1 hour. But and this is the name of the commit. So similar to what you just input. So as you can see, you can only fit just a small number of characters over there. So for the first line of your commit message, you want to stay below 72 characters. It's not a hard limit. You can input anything you want, but it's most often you stay to around 50 while still giving an interesting message. So it's complicated, but you have to sum up in one line. And then you can like leave a blank line, and underneath you can add a few more lines saying everything that you did. So if I go back in the history, I think, yeah. So this one, for example, I have. So this is the name of the commit, and underneath I have what I have done, which is explained in a few lines, also quite short. But you can just input as much as you want over there. Is that clear for anyone till that point? And do you have your first Git commit in your repository? Okay, very good. So now, yes.
So now that you committed it, it's no longer on your local machine. Is it also on a server somewhere else?
Okay. Yeah. Okay, so what I just did is say, take these changes and save them in fact, it's over there. It's in the .git folder in a compressed way. But for now, we have no remote servers. So the power of Git is that it can be used only locally, just for you and the future you to track your history. And I mean, I use it most of the time on my projects. I am the only the one working on the project, but I use it with myself to see at each time what are the features that I added, the bug that I fixed, and everything. And then you can put it in a remote repository, but it is not compulsory if you are the only person working on it.
I don't want to get too far ahead. I just wanted to see at what point we're going to push it out on the server, and the question then is who can see it.
Exactly. But for now, everything is local. It's I mean, it's some hash and compressed way in the Git repository. So what Git internally does is store the differences line by line, because most often you will define only a few lines, and it does not store the whole state of each file, which is why it's very efficient. And okay, so now, because the first time it was fun, we are going to do another commit. And I'm going to hopefully show you a few different things. Another use of Git log is that you might want to see a more concise view. And for that, you're going to input Git log. And I'm going to do -- which stands for long options, and one line. And as you can see here, you have only one line. When you have multiple of them, it's much more nice. Okay, so now I'm going to switch to VS Code, because that's what you normally are doing. You are not creating and editing files with Vim on the command line. Only Linux Guru are doing that. Everybody is using a graphical user interface. So I'm going to just modify the file. So going back to the I'm editing on Vim, I can do the print over there. And as you can see, one very interesting thing appeared over there. So I'm going to, come on. I'm going to go back to what we had. And as you can see, if you look over there, there is nothing. And as soon as I input something, there is a green line which appears. So here I have a purple color theme, because that's what I was working with yesterday, but I can change it. But I like it, so I'm going to keep it. And as you can see, this is called the gutter. It's the little side of the window. And this is used by VS Code to show you in a subtle way that these lines have been modified. In this case, it's green, so these lines were added. If I want to, for example, modify the first line, I will have a different message. So I could say, hello, Harvard, and the world, for example. And as you can see, I have some blue now, which says, this has been modified. I'm going to save that. And I'm going also to, I don't know, add another file, which, for example, another feature, which will be on a separate file. So it will be a computation.py. And I don't know, I can like add a small function in it. And a little docstring, because it's a good thing to add a docstring to your file. So, okay, not very interesting, of course, but it's a fact. And now let's say that you are using it also in and I have to import it, of course. Okay, so now let's say that I have, let's say that I'm happy with this new feature, which is the add function, which is really revolutionary. I can test it. It should be working Python file. Yeah, it works. So 1 + 2 is equal to 3, which is good. So let's say that I'm happy with everything that I added. I'm going to commit it. And here there are a few interesting things that appeared. So first of all, I just used a file on Python and I imported it. And what Python does, is that it compiles the file to some bytecode and it stores everything in its package to speed up the further imports. But these are binary files, and binary files are not really well used in Git, because it stores, there's not really a way of divide everything into line and compress it. So what Git does for binary file, it's just save them at each time save them entirely at each time they are committed. So it's not very efficient, especially each time you're going to change computation.py and re-import it, the PYC file over there will be changed. So you don't really want to import that because it will just add up and clog your repository with useless files, which will be recompiled on anybody else's computer anyway. So here I'm going to add a special file, which will be really useful to you, which is recognized by Git. And it has a special name. It's called dot, which is for so a hidden file, .git ignore. So as you can guess, as you can see, the little Git icon appeared over there. The Git ignore file, I can do enter. And this file is used to say every file name in this do not take into account. So if I go back to the shell, I'm going to open a shell in VS Code because it's much easier. If I do git status now, I have a lot of things that appear because I have some modified files, which is the script.py and untracked files. And as you can see, the pykh folder appear. I don't want to have that yet. So I'm just going to add __ pykh and save the file. And as you can see here, the little u stands for untracked. And as soon as I save the file, it disappears. And that means Git does not see the file. It does not take it into account. And if I redo Git status, it disappeared. So this is very good. Do you all, are you all able to follow along? Do you have any questions? I'll take that as a no. So now I'm going to do everything visually because that's what you are going to do. And go in the source control folder in VS Code. So here I have some changes and they managed to compact all the Git status information over there. So as you can see here and here we have the same information, but here it's a bit more concise. So I have some untracked files, which are the .git ignore, the computation.py over there, which are untracked. And there is a modified file, which is script.py. And I want to add what I just did. So for now, I just going to add the git ignore separately. Another good practice is not to commit everything at once because it makes tracking the history of your project a bit more complicated if you have, so for example, there is some part that you documented the files and you have some bug fixes and you have some new features and you have, you don't want to commit all of that together. So for example, if you have a new feature, you commit just that new feature. And then each bug fix, you are going to commit separately. And then the documentation, you do that also separately. So you will end up with a few commits, but you can go back to only one, just for example, see who edited the documentation and who added a new feature which was full of bugs, for example. This is really useful. So here I'm going to add a special file, which is the git ignore. I'm going to do that separately, and a meaningful commit message, which is always complicated to find, would be like add git ignore. Yeah, I don't have any idea for that. It's pretty straightforward. And I just click commit. So I tap my message and I hit commit. And here, if I redo git log, so I'm going to do one line, all to see all of them, and also graph because it's, yeah. As you can see, I have now a second commit in my history, which is the add git ignore commit. I'm going to speed it up a little bit because you all seem to be following along really well. I can, on VS Code, click on the file in the Git and in the source control panel, and this will allow me to see the previous state of the file and the new state of the file and compare them and add selectively to the index. So here as you can see, if I do this, so this is the previous state of the file, which was only the one print hello Harvard, and this is the current state of the file that you can see over there when you are editing it. And I want to only add this and this because it's my new feature. And this is like, for example, a new user interface. And I don't want to commit that yet. So what I'm going to do is use VS Code capabilities. I do that all the time because it's always you to work on multiple things at once and then commit just separately. Is you can select the line and do a right click. You have all these options, but the one that we are interested in is stage selected ranges. And this will say, I selected only one line, add this to the index. And Git is able to do that. And now, as you can see, this has been staged. And I can also add this over there. Yeah, do the same. It is a pin. Yeah, that's about all. And yeah, I have some problem. This disappeared, so I'm going to add this also. So I have even a custom binding, which is add as, which is very useful. Okay, so now I have my new feature, and I want also to, in order to have a properly working feature. So, for example, if Eder is working on the file and will import it from GitHub, I want him to have the full feature available. And so I have to add also computation.py. So I'm going to do that using the little plus over there. And
another place for selecting events is really useful is if you have some code that just works, right? You did some print statement debugging, so you put in a bunch of print statements. And when you want to put your file, you want to say, hey, ignore all my prints. I'm not going to add those to this commit. I'll delete them later, but I know that it's actually working right now, right? And so here, if you add all the prints, but I can also choose to not add print statements when I'm fixing whatever bug I fix.
yeah, that's a very good point. Yeah, it allows you to really work selectively on what you are doing. As you can see now, I have this everything here. So changes, so script.py, which has these changes were not committed, and this is in the index, so it's in the stage area. If I go back to the slides, it's over there. It's in the index. I think that is. I hope that is clear for everybody at this point. And okay, so now the same as before, I'm going to add a message. So it's always in the imperative file, in the imperative style. So you have to say this commit and then your commit message. So this commit adds a computation feature, for example. And commit it, so you can do control enter, or you can do commit over there, or commit over there, or you can do. Okay, very good. And now I'm going to, let's say that I want to, you can edit over there, which is quite practical. Okay, let's say that you're happy with this feature. I'm going to just edit. Okay. Finish, or let's say it's a user interface. Okay, so now I should have 4 commits. If I go back over there, yeah, I have 4 commits, and as you can see, there are all of them in the reverse order, so the most recent one at the top. Is that clear for everyone? Did you manage to do all of this on your computer? Yeah, they are all sleeping. That's good. Very well. So now, what do I want to show you? So one thing that you may want to do is, let's say you have a huge code base, and most often, I have to explain you the concept of branches. And for that, I'm going to use this little website, which I'm going to put into English because you aren't going to understand anything. And sandbox. Okay, good. So here I have it's a tool to help you understand a bit better what I'm doing. So I can just directly do some commits because it's ready for that. Okay, so we are at this stage, more or less, we have 4 commits. And Git works by storing the history of your repository in a tree. So there are some maths behind that. And the tree allows you to store everything. So if you, for example, think about how you are editing a text document on Microsoft Word, you are going to, for example, type some text, then do some formatting, then add some images. And you can go back and forth in the history, but in a linear way. So you can hit Control-Z or undo and go back, for example, remove the image. And if you do redo, it will re-add the image. But if you are back in the history and do a change, like type something, it will break the forward history of the repo. And it does not really create a parallel history where you just change. Git is used to do that. So you can, this is mostly used to have multiple people working on different things and really allow you to separate your features. So let's say that for now I have my code base and I want to add a subtraction feature, which can take some work, and I don't know yet how much time and if this is complicated. And for that, I'm going to create a branch. I'm going to show you in this editor because it's nice. So the creating branch, I don't see if you can see all of this. Yeah, if it is clear, but I think it should be okay. The grid, you use the git branch command, and you want to give meaningful names to your branch. So for now, if you are the one who is proposing the feature, you might want to call it with your username. So I'm using my full GitHub username over there. And then the name of the feature. So it will be subtraction. And as you can see now, I have 2. Yeah, I'm going to change the name because, hold on. I'm going to change the name because they don't like long names. So I'm just going to add a git branch subtraction. Okay. So now I have 2 pointers which point towards the same commit. Now I've created a branch, but we don't see it for now. And I'm going to say to Git, go work on that branch using the git checkout command, which is maybe not very intuitive. Git checkout the name of my branch. Okay, so I have a little star which says that I am on the sub branch, and I'm going to work on this and do some commits. Okay, and now it changed the color, but you don't really understand it. So I'm going to go back on the main branch. It can be, depending on your installation, I think for the recent one, it's named main because they changed that. But previously it was called master, so it depends, but each one of the other. I'm going to go back on the main and do some commits. So for example, usually the main branch is where you have the everything is working on the main branch. So it's not on big project, it's protected to only the core maintainers because you want to have only releases, for example, on the main branch and have a very clean state. And you don't want to have all the feature development and everything. This will be in other branches. But on main branch, you can do, for example, little README changes or documentation changes. It's not really impeding the projects. So I'm going to do like 2 commits over there. And now it becomes to be interesting because as you can see, I have my main branch over there, which have some commits. And here I have my sub branch with some work that has been done. And there are two parallel history of the repository that live together, but they don't interact yet. Is that clear for you till now? Do we have any questions? I don't think so. Do you have any questions yet? This is in the link on the slide.
Presentation, yeah.
Yeah, it's learn git branching.js.org. But we're going to do that in the real repository right now. But is the concept of branches clear for everyone? Yes, there is. It should be like git branch list or just git branch. Yeah. If you do git branch, you can see over there. It's lists all the branches, and then you have a little star next to the one you are currently in. Let's say that you are happy with your new subtraction groundbreaking feature, and you want to put it in the main domain so that it's a new feature. Publish it. You are going to do what is called a merge, where you merge the two histories of your repository, and both will be kept. So you can have some conflicts. We're going to show you that a little bit later, even if I don't want to, because it's always gets messy. But you are going to merge it, and to do that, you are going to go back to the main branch and do git merge, and the name of the branch you want to merge. And you can even do octopus merges when you merge multiple at once, but you don't do that usually. And here we are. We have the git the branch sub. It did not disappear, but it stays over there. But now all the files have been merged together, and the commit over there combines. So if you go over there, the files will combine the new feature and what you added in main. Is that clear for everybody? Okay, they are still sleeping.
So the typical workflow for me is I have my main, I can just push to the main and pull the main and work on it. But I find that I can get messy. So when I want to work on the feature, how this branch off and merge. So because that way I keep my main essentially me. I don't introduce everything. I know that's the work in progress. It's also great for like collaborative work. And then we'll see what we have pull requests so that other people can say, yeah, this is fine. That's a percent. But I think there's a saying that's branch often. I think is the merge and branch off.
Yeah.
That's usually set in.
Yeah, definitely. As soon as you want to add a new feature, you want to do a branch to keep. Even if you are the only one on your project, you want to keep things clean, even in your head. And then you will have a bit of work to do in Git, but that's fine because we know how to do it. Okay, so now we have this little graph, but it's a tool. I'm going to do that in the real repo, and I'm scared. Okay, so for now, if I do git status, it should be working pretty clean. It says working pretty clean. So, okay, let's do the same. So git, do you remember the name of the command to create a new branch? No, you were not listening. That's bad. So it's git branch. It's relatively git branch, and then as I said, I want to have something short but very descriptive. So I'm going to put my name because I'm the one who is maintaining this new feature. So it's my GitHub username, which is very practical and short. And then the name of my new feature, and I just press enter. And as with most Linux command, as you can see, there is literally no output. But now if I just type git branch without any option, I now see that I have two branches, the master that I'm on and my new branch. That is good. Yes.
So you earlier when you just the name like the now why do you have to put like your name for it and then like that?
Yeah. Normally what I do is do this. And on the website, I did this because they were shortening the names. So I had to do something small. But what you want to do is to have longer names. Because if you're working with, if it's a big project and you're working with multiple people, let's say that you are doing like some finite element codes and you are the only one doing that. And then someone else is doing the graphical user interface, but also updating some files and everything. You want to have everybody has his own name and then you can group them and it's easier to see. That's why I did this. And now I'm going to work on this new feature. So I'm going to git checkout and the name of my branch. And as always, I'm lazy. So I'm just like the first letter and just tab and it auto completes because there is only one branch.
It also prevents conflicts between branch names, right? So say Louis and I want to do both work on the GUI. I call my branch GUI, we call this branch GUI, we're on the same branch. Whereas I call my EM backslash GUI, those are elevated backslash GUI from very obviously branches. And it also keeps like kind of accountability branches simply worthless.
No, definitely. It's a good point. And even for you, if you have all of your branches with auto completion, you just have over there, you can just say tap your username and then you know they will all be over there. You don't have to think about it. Like what did I name it? You can just list them as you can see, and they will be over there. So git checkout and it says switch to branch, the name of our branch. And even over there, before we had master and here we have only this. As you can see, I did this with a clean working tree. This is not mandatory to do, but it's you most of the time you want to work with a clean tree to when you change branches because it allows you not to mess up, which I did a lot of times, unfortunately. One command that you can do to use that is just use the git stash command, which allows you to say, I'm working on this, put everything in a stash and keep it for later. And then you can git stash pop it.
Actually branching from the previous command. So if you have modified pull those in, that's whatever branch. Those numbers are kind of getting that's
Yeah, because they just stay.
Yeah.
Yeah.
I prefer to commit and keep everything clean and then
One thing you can do also is you can, as I said earlier, Git is useful because you can go back in time. And you can do over there, so I don't have any files there, but I can just go over there and do a commit starting with work in progress. And I say I'm working on this. So for example, work in progress documentation. And I commit that and go back to the other branch. Everything is clean. And when I go back and can do just a git reset, a soft reset. So it's like git reset, something like this. I think it's something like this. When you type this, it will just go back to the previous commit. It will just delete the commit from the record and give you back the files that you were working on. You can do that also pretty easily.
and if you want to I always go to the cheat sheet. It's very best because if you pick them up, typically you get at so yeah, there's a cheat sheet at the end of the slides. So you can just all go to Google get cheat sheets. People don't.
Yeah, so it's very clean. It's made by GitHub, of course. And so you have like Git add, Git reset. You have everything over there, which is explained. So it's not short, but
Pretty sure there's also a bigger meeting with PowerPoint that says, just learn how to do this. And you don't know what to do.
yeah.
Like it's a work in progress.
And it's a very complex tool. Yeah, and you can shoot yourself in the foot very, very easily. So yeah. Okay, so now I have a new branch and I'm in my text editor. I'm going to just work on that. So go back to computation.py. And so here I'm lazy and we say it's a subtraction feature. So okay, my new feature is done. This was pretty quick. I'm going to commit it as always, so it's clean and everything. So now if I do git log, always one line, and with the graph option, you can see that I have a new branch with my new feature. And now to show you the merge, I'm going to, I might want also to introduce some conflicts to show you everything at once because it will be more fun. So I'm going to modify also the main script.py file and mess with it. So this one I can say like test, for example, and then I can remove all of that because it was just prints and it's not really important to the core of what I'm doing. And I can say like, for example, cleanup. Okay, so this was a bit quick. I'm sorry for that, but we have to get going. Okay, so if I do that, I have a few things on those branches. I'm going to go back to master using the checkout command and do also some work over there. So as you can see, I'm back in master. You can see it over there and change in VS Code directly. And as you can see, I'm on the master branch, and this shows you that if I go to script.py to computation.py, my sub feature is not there because it's on the other branch. And the same in the other branch, I deleted all of this and I added a print sub. It's not there because I didn't do that in the branch. And now I am going to introduce some conflicts between the two branches to show you how fun this is. As you can see, there is a little red triangle to say that you have deleted some files, some lines in the gutter. I'm going to delete this. And this one will be difficult to find a meaningful commit message. So I'm going to remove the wall. Okay, a lot of fun, as I said. Okay, so I hope this is not too messy for you because I'm going quicker and quicker. To sum up what we just did very quickly, we wanted to start a new feature, which is a subtraction feature. I created a new branch for my username / subtraction, made my feature, so I have a few commits over there. And as you can see, now I have the two branches. You can see them over there. And on the main, on the master, I also did a few things. We can even see it in the graphical user interface because why not? So here I'm using a graphical user interface, which is called a Sublime Merge, which I really love and can be useful. I recommend you to use one because it allows you really to see the branch is and everything. And it can save you really. So documents, Git presentation. So I'm just going to open that folder. Okay, as you can see, so it's quite clear. And I have two branches, one which is master and one which is LGT subtraction. As you can see, you have the separate history of the files. If I click on one commit, I have what I added in green, so it's pretty readable. For each commit, it's really useful to see what changed. And now I want to commit and commit this and do the merge. So let's say that I'm happy with the subtraction feature, which is without any bugs and anything. And I want to commit it. And I'm going to clean that up a little bit. Okay, very cool. Let's go. So I can do it by doing the git merge, and then I'm on master, so just the name of the other branch. I'm not going to do that in the command line because that will get messy as I have some conflicts. I'm going to do it in the, can I? Yes, I can, in the, I'm sorry, I'm lost in my mind.
You can do it in the command line and then you will resolve the commits, the conflicts anyway, right?
Yeah, definitely. I don't even know how to do that in Git, in VS Code. I'm going to do that by hand. So as always, git merge and then the name of my branch. And when I press enter, there will be some conflicts, hopefully. Okay, so it says auto merging conflict, and I have a merge conflict in script.py. This means that two people, or you and you, modify the same files, the same lines, but differently. And so Git says, I don't know how to resolve this. This is your mess. Deal with it. But it helps you a little bit so you can see conflict. And over there, I'm merging. And if I go back to VS Code and my script.py, this appeared, which is a visual way of saying you have some conflicts. So it's not really clear to be used to that. But on the top, you have the change that you made on master, and on the bottom, you have the one, it says incoming change because it's on the branch. And as you can see, it's separated by these equal signs, and there is nothing on the subtraction branch because I removed all that block. And what I'm going to do here is modify the file so that I have something which I am happy with. So the people that should be doing the merge should know about the project and not be just some random guy because you are going to modify the file just what you need. And so for that, I'm just going to, let's say, I don't want to remove everything as in the branch, but I don't want to keep everything. So I'm going to do that. And you have some buttons like appset boss, you can compare them and everything. And yeah, I'm going to just manually remove that. And yeah. So now this is the version of the file that I'm happy with. And so you have some merge changes. Just add this and then commit. And by default, you have a commit name, which is merge branch. The name of your branch, you might want to keep it most of the time. Okay.
So in the merging process, it's on a smarty in the background. It said, okay, I can merge these files and these files without conflicts. They all know. I can change things here and here. This is all fine. And it will only give you this kind of merge conflict with this like kind of equal signs and arrows. If it's saying, oh, two people modified this file, like I don't know how to resolve this. So like you might not have to even deal with this if you know what you're modifying and you don't modify the other main branch at the same time, right? So that's the only reason why this popped up. There was a new feature that you were adding. You said, I'm not touching main for a while. I can just merge the feature without having things. But rarely does that happen. Sometimes you end up secret here. So you have to resolve merge on this.
Yeah.
That's scary.
Definitely. But most of the time, I'm going to show that when you do on GitHub is that you do what is called a pull request on GitHub, and you have a visual way of doing it, and it's much easier. And what Git does, it's just for each file that you did not touch, is take the most recent version. So if you change everything on main, it will just take these versions because they are newer, and then just add your changes because they are newer. Okay, so if I read you the git log command, you can see now that I at the beginning, and then I had a branch, and now it's merged. And if I go back to my files, you can see that I have the new state of my files, the feature is used over there, and in computation, everything is there and everything is working. And so I think I've covered most of the things that I wanted to talk about in Git. A few things linked on the VS Code because it's really useful. As you can see, if I click on a line, I have this little gray text, which is not some real text which moves, but is some information if I hover it. This is the Git information provided by the Git length extension, which I installed, which is really useful because it allows you to, if you type online, so for example, who added this sub feature? You type on it and you can hover it and you say, it's me in this case. So you have my little profile picture, the date. So it was 10 minutes ago. The name, so it's a 7 characters name, the shorter name of the commit, the hash, the line that was added. You can compare the changes between the two commits. And also you have name of the commit in which it was added, which is also over there. So you have all of this information, and you can even do what is called a git blame, which says, oh, so this was added in the finish user interface commit, and this was added in the add computation feature. So yeah, everything is very, very concise, and yeah, you can do this. So this is like in the computation feature, in the subtraction feature. And so for this one, it's really, it's a mark example, of course, but when you are working over more complex features and with more people, you can directly call the people who added the bad features, and it's nice to have. Do you have any question till that point? Were you able to do everything on your computer? And yeah, okay, good. That's all for Git. Goodbye. Now I don't know what can we add to that.
Just maybe like a quick summary. This is what a version control looks like in code. We're all kind of used to now that Google Docs have to be saved automatically, being able to go through the revision history and modify files there. Git code world doesn't have that necessarily, like auto save feature, the history. This is the best thing to do. No one knows all the commands by hand, so I still look everything up. Or things sometimes still look hard. But yeah, typically branch often, word often. Yeah.
Yeah.
It's a good way to be update or organize.
So no worries. Yeah, I agree with everything that Eder said. So to sum it a little bit, yeah, I work with Python files because it was an example. Git is designed to work with every text file, so not binary one, like for example, a Word file, PowerPoint. This can work, but it's not really useful because it's just changes, stores everything at once. You can add any type of file, more or less, but you want to add text files. So this can be Python files, C++, LaTeX, I don't know, everything. So that's really useful because in one repository, I could show folders, maybe, because it was the same. I could show that.
Big thing is if you're I think you have this model that everything's being stored, nothing gets deleted. That will, you can see how this folder will start flowing. I keep putting in new data or changing all the data file. It's keeping the old data and just adding the changes stored, right? So typically that files are lightweight, so that's how you can keep those. We ignore the binary file.
Yeah. Definitely. So for example, if you have a LaTeX file, you store the LaTeX file and maybe the BibTeX, but that's about all. So you would add to the Gitignore like the computation files and the PDF, the generic PDF. The aim is that for like a C++ project, you do not store the output binary. You leave it to the people on their computer to do that.
So if you were using Pollet, you have like Pollet, want what you want to still add in like as a game operation. Like I want this one. Okay. And I guess the other question is a lot of the people here are current Katya's group, but not everyone. But you know, with Abacus, for example, and a lot of us use, there's like a ton of files that get generated all the time, and we don't want to save, right? So now Git ignore would be helpful to cancel that all out. And it's the kind of thing where like every project will same set of files. Is there any like good practice for when you have sort of a standard set of things that you want to ignore almost globally across your computer? Like, is there any? Do you just have to manually copy that into Git ignore every time you make a repository, or is there any higher level thing?
So yeah, two good questions. The first one for the binaries generated. On GitHub, you have a way to do releases where you say, this is a good version of the project where I have these features and everything. And in these releases, you have the ability to add some binaries. So that's how you would do it. And for your
Export, and then you force that one file that it doesn't.
And the second question is, what was the second question? Yeah, no. Yeah. If you go in the Git cheat sheet, it's written over there, I think. And I saw that, and this was really interesting. So this is your answer, which I didn't know of 50 seconds ago. So there are two things that you want to do. So GitHub has prepared a Gitignore repository, which is called GitHub Gitignore. And as you can see, you have a lot of things. But I don't think there is Abacus. No, it's not over there. But for example, on a Python Gitignore, it will talk to everybody. So you would just copy that. But you can see there's the package. There is the like every binaries and everything. Yeah, it's quite extensive. But
come up soon. You get a chance to start the repo from scratch by this file.
Yeah, definitely. So you can like craft one for Abacus and just copy one every time. You could do that, but yeah, as you can see visibly, you can do with this command a system-wide ignore pattern for all your local repositories, and you can do that basically. Yeah. Yes.
If you just don't add it with them, that is the thing.
This will, I mean, every time you do like a Git status or in your local changes, it will appear. So by mistake, if you like add everything, or even one other thing is that when you are collaborating with people, if you don't have a Gitignore pushed to your remote repository, people will also, if they run the Python files, they will get some bytecode generated. And if they don't know really well to work with Git, or they might add them. And then you did not want to, and you worked all this time on your own without adding the binary files. But then suddenly the first person who comes to work with you will add the binaries that you don't want to do. So you will, yeah, you can remove them, but it's not really critical.
There's one command that I never recommend using, so that it's useful. Git add period this directory, so that is add everything. Like the ones that you probably ignore. If you add them, if you ignore it, it won't use it as a sparingly.
Instead of like you screw up an accident, you know, accident get a 3-day commit, which talks about like ideal long term history, but if you know something was really a mistake and you want to like back instead of what is it, or is that just ignore never?
Depends on how much time you want to spend on Git operations, but Git is really powerful because you can edit the whole history. Like if I go back to my Sublime merge thing, as you can see, so I have my branch over there, which has been merged, but my working tree is clean, but I can just right click on the commit and then edit commit. So I can edit the commit message quite easily. I can edit also the commit content. So this, yeah, it's in the branch, so it can't really do that, but yes, you can. But
Not recommended, right?
Yeah.
History is mentioned that we got.
But it's easy if you messed up. It's the last commit and you commit and then you realize you can do something which is called just the one before, for example, you can reset master to this commit, and you have options, and yeah, you do something like soft or mixed, not hard, because this will just delete all the changes. Already done that. I don't recommend. You can do just a soft reset, which will just say, okay, this is not committed, but all your changes are still over there, and you can just remove the binary. It's not really good. But it's not that it won't work, it will, but it's not optimal. Yeah, so to sum up, this Git is for text files. And another thing that I might want to show you is that, and I mean, this, what I'm going to say is also, you can apply it to everything is computer science, is that use Google. So for example, let's say that I have some situation and I want to Git merge multiple branches. I don't know what you would do that, but sometimes you want to. You just type that to Google and you immediately have a result, which I already clicked on when I was preparing this, which is a Stack Overflow question from 11 years ago. So 11 years ago, someone had the exact same question. And so you have the question, you don't read it. You go to the answer, and someone also 11 years ago already answered about that. So you just Git pull everything and then it works. So for example, Git remove file from commit or from whole history, which is literally your question. And this means someone messed up, and because sometimes you like add some secrets also. So you usually in this field you will not have that, but you would have like an LWS or a key, which can get very expensive, or everything like that. And you can see a lot of people found that useful. You can do that. But this is a complicated command. You won't come up with that on your own. Either you read the Git doc, which are really good, or you just go to Google. I think it's over there. So this is the main Git website. And yeah, the documentation is over there. So if I go, for example, Git reference manual, the most basic things are over there. So for example, Git add, and you have all of the things. If I do this, for example, as you can see, you have the same things written here and over there. It's the same, but you'll have a whole descriptions and all the options really explain and details with, and even some examples. So if you have a dot, just go over there and read the examples, and you have, yeah, I mean, you have everything. It's really, really, really detailed. So I recommend doing that. Okay, so welcome to the second part of this talk, which is GitHub. So as we have said, is a decentralized version control system, which means that you have your own working copy, which is independent and sufficient to work with, but you can also publish the work that you are doing to a remote server. And most of the time, these servers are hosted by mainly 3 companies, which are GitHub, GitLab, and Bitbucket. So they are just hosting your Git repository and allowing people that you select to access them and collaborate with you. So the one that we're going to present today is GitHub, because it's also the one that is used by Harvard, of course. So it's hosted it's the enterprise version hosted by Harvard, but it's the same principles as standard GitHub. And so I'm going to show you like the process of publishing a repository and then what we can do with this repository. Let's get started. So for that, I'm going to leave the command line. GitHub did publish a very useful command line utility, which is called a GH, that you can install. And it's very useful because you can just clone repositories, even if I didn't explain what is cloning a repository. You can do a lot of things with GitHub from your command line. So it's for Linux gurus. But here I'm going to stay in Visual Studio Code and go to my GitHub profile. So let's get started. So to do that, I'm going to close, just close a bit everything. Yeah. Okay. So okay, this is my GitHub profile with my very professional picture, and as you can see, you are welcomed by. So yeah, I'm going to explain everything as you are eating, so you have some time. You have the real GitHub page is that you never see, of course, is this one, because most of the time you are signed in. So on this page, they explain everything, why they are the best company in the world. They've been bought by Microsoft a few years ago. Yeah, but it's nice. Okay, so this is my GitHub profile. If I do this, maybe this update. Yeah, most of the time you had one or a code at Harvard .edu. Yeah. So this is my personal GitHub profile. So here you wouldn't have, if you didn't personalize this, you don't have that. You just simply go to your main repository. So these are some repos that I pinned because I like them. The contributions that you did, like year by year, so there are less and less, as you can see over there, and some contributions. And then some organizations that you are part. So this is my the robotics club of our school. Like some of them, I'm a pro, of course, as you can see. And recently they did some achievements.
You can have
your students and access to the co-version for free.
Yeah.
You have more features and have shared repositories, you have insights, you have more statistics. It's cool to go into GitHub features for that.
Never really use that. But hey, okay. So this is your GitHub profile. You have different tabs, so you can, for example, stars some repository that you like. So yeah, it's mostly random. It's the repo that I like. You can publish packages, have some projects, but the most important one over there is the repositories. So on GitHub, all your pretty intuitive, or each Git folder will be stored as a repository, and you can work within this repository and do a lot of things. So you can just, so this is a recent one, but you can, like, for example, see on my Python repositories, which is like 18 of them. Yeah, so that's a lot. So for example, this is a school project. This is something that, this is Django, which is a web framework, but this is, I did not create it. I worked on it. So it's a copy of this repository. I can do a lot of things. But for now, what I'm going to focus on is how to create a new repo and publish it. So there are, as always, multiple ways to do that. One way to do that is there is a little plus over there, and you can add like a new repository, import a repository from another Git remote provider like Bitbucket or GitLab. Add a new organization in a project, a new gist. A gist is when you just want to have, like, so for example, you have a small script to do something and you want to show it to the world. You just publish a gist and not, yeah, just like sharing a file and not a full repo. For now, I'm going to focus on new repository, so I can select the owner of it. So it can be an organization, and a few options over there. So I can add a repository name, a repository name. So for each time I chose, they propose some names, of course, but you have to find a useful and short name. It can be like company's names, which mean nothing, but are fun and easy to remember. It can be, I don't know, I have one which is called like CV Maker, which I used to do my CV. Of course, it's already taken. I don't really know about that. And then you can choose options like, will it be public or private? I can add a README file, which is highly recommended, which is a file that sits on top and says, hello, welcome to this repository. This is used to do that. Basically, a Git ignore template, Connor was speaking about that earlier. So for example, if I tap Python, I can directly add the Git ignore template, and I don't have to like copy it. And a license, if you're doing some pretty consequent work, you can use like the Mighty license, which is permissive, or the GPR version 3, which is more restrictive. There are a lot of them. And then just create it. What I can do is create it over there and then set it up in the command line, or just publish it directly from VS Code, which is what I'm going to do because I am lazy. So I go back to VS Code and go back to there. And as you can see, my working tree is clean. So this is what I did over there. So this block has been done by me 38 minutes ago. And I can directly publish the branch. I'm going to go over there. And as you can see, when I over it, there is the name of our repo. It's Git, because I didn't talk at all about that, but there are also other version control systems like Mercurial or SVN, which are less and less used today because Git is the most recent one, is the best choice. And there is a return published to GitHub because I'm already logged in VS Code with GitHub, which is why if I click over there, I'm logged in. So I can, I'm going to move my face over there. I can just click publish, and then it's a small prompt, but I have to choose a name for the repository. So it will be like Git presentation. I'm going to call it Harvard 2022, short and easy to remember as always. And I can choose to publish it at private or a public repository. This will be a public one for once. I don't know, you can choose, like, for example, most of my projects, I open source them, so they are all public, my personal project. Florent on the other end has a lot of projects, but they are mostly private.
It's depends on what you start, what purpose.
It's a personal choice. If you have a brand new company ID, you might want to set it private, of course. But this time I'm going to publish it. You can change it later, but I mean, if it has been public, yeah.
So if you want to start private, you can.
Definitely. So I'm going to publish to a public repo.
I'm just curious if you have one in your Pollet group where you share.
In the GitHub Enterprise. I don't know how it does work, but we do.
We use an organization usually.
Yeah.
So
That's what you can do in GitHub, Joe. I can show it over there. So I said I'm part of multiple organization. I can do that. For example, this is our this is our robotics club, and we have an organization. So if I go over there, organization, as you can see on GitHub, the URL are very simple. It's github.com/username. It's very simple. And if I go over there, this is like our organization, and you have different repositories that belong to the organization, and you can add people over there. So for the build.od group, maybe we have one, but we all know about each other on GitHub, and you can add on each private repos.
But Professor Pollet,
Definitely. Yeah. Yeah, exactly. So here I think it worked. It worked, and as always, it said absolutely nothing. So now this change, and I don't have published to GitHub, I have sync changes. If I go back to my profile, which I will do going into the URL directly, because it's easier to do. You can see that I have one more repo over there, which is 67, which is way too much, and created two repositories, and yeah, it's over there. Just created, and as you can see, the date over there is the date of the commits, and not the date of the when I added the repository to GitHub. So you can take like a 2-decade-old project, convert it to Git, and then put it on GitHub, and the commits will show as old. Okay, so this is my repository. As you can see, I didn't end what I was doing earlier. Okay, I'm going to show all of that. So this is my repository. So to present you a bit this page, it's a bit overwhelming because they added a lot of options over the year. And I've only been using GitHub for 2 years, and they have existed for like 11. But a lot of these things were added since. So you have the GitHub logo, of course, a search bar, so you can search in the repository, in the user, or in the whole of GitHub. You use the name. So this is me. This is I own this repository. I'm in Cambridge, Massachusetts, and everything. Some emojis because, yeah. And the name of the repo. So you can see it's very simple. And as you can see, the URL is also pretty simple. It's a public repository. The main part in the welcome page is the code. Of course, it's what you are interested in.
So if you type the URL, you may be able to type it because it's public.
Yeah, I think if I go on Google, maybe not, because it's. Yeah, it's a bit too soon. But if I type maybe this, no, it does not work. Okay, you have to be famous to be in Google. I can do a few things. So here you have your code, which is the main part you're interested in it. You can click on a file to see it. It's not really beautiful, but it's not used to really see the code. You have to import it. It's way better, but you can see it. It's over there. You won't be able to run it that way, but you can see it. And now that it things for Python, like if I click on this, I see the definition of this function and can click on it and go into the good file, which is quite useful. Okay, I'm going to hurry up because I have a lot of things to show you. I have the commits history. So as you can see, they are all there. They are not really separated between the branches. They are all shown in a linear way, but the branches are still over there. So this has been done in the subtraction branch, but it's not shown as such. I can change between branches over there. The branch subtraction disappeared because it's not active. It's a previous branch, so it does not appear, but here you would have all the branches. In order to work and maybe show you funny things, I'm going to go into settings and add Florent as a contributor to this project. So again, everything changed. You can add like a public social preview if you share this repository. You can add a lot of things, be sponsored, as some discussions. Yeah, you can delete this repository, make it as an archive, transfer it. I could transfer it to Florent, change it to be private, everything. I'm going to go to access collaborators and I have to retype my password. Okay, so now I'm relogged in. And so this is a public repository. That means, what does that mean? It means that everyone can see the code and propose some changes, but they can't change the state of the repo. I'm the maintainer, I'm the one who has power over that. But I want Florent to be able to collaborate on this repo without having to create something which is called a fork. I can fork this project over there, which is stupid because I own it, but Florent could do that, which means create a copy of this repo, and then you can interact with it. They remain linked. This is useful, but I want to have Florent as a direct collaborator, so I can invite him, and I know his username, and it's over there. Just add him to the repository, and now he should get an email and a GitHub notification. So, for example, for now, he's invited. He just accepts the invitation, and that was quick. And now he's a collaborator. So what we're going to do is maybe you can share your screen. Can you do that?
Yeah.
So,
But I think they are. It's fine.
okay, very good. So now you can see the screen of Florent. And what he's going to do is go into his file explorer and open a new Git bash instance. C'est pas ce que j'ai dit. Bon, ok, vas-y, redis. Okay, so now what he's going to do is go back to GitHub and click on the green code. And as you can see, there is a lot of things you can open with GitHub Desktop, which is really good. With the GitHub CLI, download the code as zip. Or also you can have the URL of the repository. So he's just going to copy that, go back into his bash and type git. So it's a git command clone, which is clone the repository and then paste the URL of the repo and type enter.
Here it's because I already
Yeah, he's logged in. You don't need to be logged in. It's public.
Like when I before.
Exactly.
And we can show how if that's for password.
Je veux pas arrêter de bouger. Okay, so what he did is that he just cloned the repository. Clone means that you have a remote repository, you like it, you want to work on it, and you just copy it as a local copy. So it will copy not only the code, but also the .git folder, which contains the whole history of the project. So now it can do like cd git and just tab, and it will be able to go into that repository. So if you do like code and dot, you can open the repository. Stop. Yeah. So it did code to open Visual Studio Code and dot to say open this repository. So if you do that, it should open in Visual Studio Code. Yeah, which he did. So yes, you trust the author because it's me, of course. It has the high contrast theme. I don't know why. Maybe put it in a bigger. Yeah. Yes, wunderbar. So okay, and now as you can see, Florent has my repository on his computer, which is what you want to do when you collaborate. So okay, now we want to show some interesting things. You are going to like create a branch called your username. Yes, very cool. Okay. Yeah, so he opened PowerShell, but it would work. Yeah, this, okay. You can, how will you name it? It's a multiply feature. So as always, he's named it. His username / the name of the feature. I can check out this new feature, and then so a new branch has been created. Very cool. And then you can like go into computation.py. Fais Ctrl-G pour un. Yeah, very cool. So you can just copy paste that and add a merl function. Yeah, very good. Which will be very groundbreaking again, which is just multiply the chain press and going back into script.py and just print. Yeah, as always. So again, a new feature is going to commit that with a meaningful commit message as always. And like multiplication feature. Okay. Have you been able to follow? That was really quick, but I hope it was clear. So just commit it and maybe do do a git log one line graph. Say one line. Very good. So as you can see, you have the history, and now you have interesting things that appeared. So you have yeah, it's not very clean, but yeah, maybe if you fait dash all. Yeah, okay, very good. So as you can see, there is the master branch, and also there's an origin, which means that it's on the remote repo. The head, which I didn't explain, but which points to the last commit that you have access to, and everything is done on the remote repo. And there is the new local branch, which is called Florent multiply, which with this new multiplication feature. And now what you can do is, we really didn't show you how to communicate with a remote folder, but you have two main ways to do that. The first one, you have two commands. One to see what has been done in the remote repo. So the first one is called git fetch, and this will not change the state of your current repository. This will just say, download what has been done and show it to me. So if you do that, yeah, of course, nothing happened because I did nothing in my computer. And then you can do a git pull, which is like a git fetch, like download everything and then merge with what I did. So if you have some conflict in the repository, it can be complicated. And then there is another command, which is on the other way around, is git push. And git push is say, I have these new commits on my local machine, push it to the remote repository. I hope that is clear. So now you can publish the branch. I think you can just copy it and replace the branch between brackets with the name of your branch. So I think you can even get away with a different name between the remote and the local branch, but you don't want to do that. So here is using yeah. I mean, I think you can just do it graphically. Yeah, you can click on publish branch. Oh, well, yeah, we git push. Yeah.
Yeah, push it with the -u option.
Yeah. Usually Git helps you a little bit. So here just say git push and set the origin. And as you can see, there is a new, yeah, you have something. Okay, cool. So now if Florent goes back to the GitHub page on his browser, you can see that it already updated. It say even that you have recent pushes, you can compare and everything. And now you have written 2 branches. So if you click on the little menu, you can go and see the new branch, and you can like go to computation.py and see that there is a new feature, brand new feature. Okay, so now I'm going to take over the screen sharing and show you a few things. Let's go back to this. How much time do you have? I think like in 15 minutes, hopefully it will be finished.
15?
Yeah. Thank you. I'm going to hurry up a bit.
That's the last one.
Avec plaisir. And if I go back to over there, and so this is Sublime Merge, I can do a git fetch, and this will show me, oh, Florent Pollet. Florent Pollet, if I click on it, so it's Florent. It's not me, it's Florent with his address mail, his mail address. And it's a new feature. So I can pull it, pull it, everything. So for now, it's on the origin branch, so it's on the remote repo. What I'm going to do is finish what I was doing earlier. So I added some folders, but they are empty. One interesting thing with Git is that it works with folder, but folders you can't just add a folder. You have to add a file, and then it will represent the folder structure. So here I want to move up a little bit in the structure of my my folder because it becomes more complicated, and I want to move to add some docs. So I'm going to go into the docs folder. So as you can see, VS Code has some nice icons to help you distinguish everything at a glance. I'm going to add a doc. So I don't know, like okay, I don't really know. Okay. Just one explanation phrase. So this model has 3 computation. And I can just say it's add sub and null. Okay. Very interesting. Okay, and now I can move my scripts to the src folder. So if I collapse everything, you can see that this is way more clean because I can have as many files as I want in the SRC folder, it will just say here, it's the code. And then I have the docs. So it's much more clean and everything. And last thing I'm going to do is add a README. The README file, which will be automatically shown by GitHub, is you can just call it README or README.md, which stands for Markdown. I'm going to call it so it's a talk on Git and given by, and I won't type the name, so we'll do that later. Okay, so I have a new README. I go into the VS Code file, into VS Code folder, and to show you, okay, this becomes really interesting. I have all my files here, but you don't see the folder structure. So for that, I'm going to click on this little icon over there, which says view as a tree, and we like trees. And it's much more clean. So I have a new file, which is called docs. Okay, so, and a README file. I'm going to add this and say, yeah, to do a proper technical talk, you have to type really fast on your keyboard, and I think I'm managing that quite well today. And so you can, and as you can see now, Git sees what I did, which is move the files as two moves. In fact, it's that it says that I deleted some files, which were the root folder, and added some in the SRC. But if I add all the changes at once, it becomes clever and say, oh, you rename them, which is not really rename because I just added src/ in front of the name, which is I added a folder, but it's okay. And I can say like clean up the repo or move to src. Okay, let's go. I'm going to sync the changes. So as you can see, I have 0 downward changes to download on master and 2 new that I'm going to push. So I can do this over there, which is more fun. Git. Yeah, so as you can see, it lists everything, compress, send, and decompress, and it's done. Good. It does. One thing that you can do if you push the binary file or something that you don't want to, it's okay. You modify your, I'm going to show it like this. Let's say, for example, I didn't want to like add this, or I can on my branch edit the commit or reset master like to this one. Do like a soft reset, change things, recommit, and then I won't see it. I don't want to do this, but there will be like this a divergence between master and origin/master. And to resolve that, you do something that most of the time you don't really want to do because it's bad. But if you know what you're doing, it's okay. And even most of the time, it fits the most recent commit. It's okay. Which is you go over there and you do push false, which says my copy is the best copy. I want my copy to be the copy under remote repo, which can destroy everything that has been done by other people, which can be bad. But if it's just to like remove a commit, a file from the last commit, it's fine. I do that also. I can show you, in fact. Let's say that I don't like, I do that very often. I don't like the name of this commit. Oh, I changed the name, but now it diverged. As you can see, master diverged. You have a little exclamation mark here. And master and origin/master are not the same. Only the name of the commit changed, but also the hash. If you look it up, the hash is not the same. It's okay, I know what I'm doing. You just change the name, I can push false. And then now the origin/master will be updated to the new name. You can do it. Okay, we are nearing the end of the 15 minutes, I think. So I'm going to hurry up again. I'm going to go back to Yeah. So as you can see, they treat the master branch as something really important, which it is. I'm going to dismiss it. Okay. So now I have a README which is shown directly by GitHub. So if you go, for example, to a famous repo, which I'm going to type by hand. It works. So this is the Linux kernel. As you can see, it has 1 million commits, which is a lot, and a lot of forks and everything. You have a README, so this one is not in Markdown, so it's not really beautiful to see, but it's over there. It's shown, and you have the whole folder. Okay, so now I can go through the folders and show the files. This is an MD file, Markdown file, so it will be rendered by GitHub, and it's quite readable. Not really, this one is not really interesting, but it's quite readable. Okay, so now what I'm going to do is say I'm the maintainer of this project, but Florent worked on it, and I would like to merge what he did with what I did. So he's going to share the screen again and show us what is a pull request. So by the time he's doing that, I'll just show explain what is a pull request. So it can go, yeah, go on. Okay, it's going to do compare and pull requests. So if you go slowly, he is opening a pull request. A pull request says, I did this work on my branch. Can you consider merging it? So open source projects will have a lot of pull requests to add features, fix bugs, add documentation, a lot of these things. So you can usually keep the name of the last commit. You can leave a comment, tag me, do a lot of things, format it properly. You won't do that, just create, hold on. You can see it compares the name of the branch with the master, like over there. Here. It's just creating a pull request, and the reviewer is me, because, yeah. Very good. So now I have a new pull request, and it's going to stop sharing, and I'm going to share my screen again. Yeah, okay, it's fun, I know. So if I go back to over there, here I have a new pull request which appeared. As you can see, they are numbered, so this is number 1. And this means that if I go to pulls /1, it will show me the. There is no S. Yeah, it works. So this is the first one. It's good because I can reference it. For example, in a commit, I can say like this belongs to this pull request, and I just put #1, and GitHub will recognize it and put a link to the good pull request. So this is really useful. Okay, so I'm the maintainer. I have a new request from Florent. I have some conflicts. Come on. I can see the different commits, the files that have been changed. I can review them, say, oh, this is cool and everything. But I have some conflicts. What I'm going to do here, because I'm lazy, I could just directly close it, which says, okay, thank you for your contribution, but I don't want it. I can open this in GitHub desktop, which takes some time, but yeah, it's cool. Okay. Okay. So, no. Hold on. Yeah, so I think I can pull request. I can click on it, and I'm on the branch, and I think I can merge it from over there. Choose a branch to merge. No. Non, je vais faire ça. What you can also do is go back to VS Code. I'm lost on this one. I'm sorry, guys. I can go back to my main branch and do a merge, I believe. Comment on fait? Hold on. Yeah, all open. So I can manage it directly from the Git. Check pull request, and then I can merge it directly. The problem is that I have some conflicts that I thought would be easy to resolve, and of course it is not. Yeah, cool. Okay, so now I have all the changes that appeared, and I can approve it. Okay, so I have to add things. So for example, I can say this is good. I can mark it as viewed, and the same over there. And comment on fait? Yeah, I'm going to add everything there. Commit, which is like a fix. Okay, cool. And then go back to the pull request. And then... Okay, this is not a good demo because this is not working. Comment tu fais?
Otherwise, you can just merge the branch.
Yeah.
Okay. Pull request.
Yeah, I'm just going to merge it directly. So this is like this will merge one commit.
So basically, request is merged.
Yeah, it should be easier to do. Yeah, okay. So I merged it manually and pushed it, and so as you can see, it has been merged. Yeah, I just merged it manually. You don't do that usually, so you. But you can do a lot of things like collaborate. Like I can tag him and say, "Good feature,"
Yeah,
and he will have an email saying "good feature."
the idea with pull request is to be able to discuss a change. And maybe the maker will say, "Oh, maybe change of this feature to be more in the project," and then I will do new commits, and then we will do the pull request, and you can have this feature because as a collaborator, I can directly merge it.
Yeah, definitely.
So
So to show you on a popular repository that you used, which is NumPy, as you can see, they had 11,000 pull requests, which is a lot. So it's new features and everything. You can add labels to it. So it's a huge project. So they have useful labels. And I'm going to pick one with some comments. So as you can see, someone did some things like typically this is small. It's one commit, which is something. And then someone reviewed, so it, yeah, is a core contributor. So he said, okay, this is good, but this could be a static function. And the creator of the commit said, okay, I can do that. Is good to you, and everything. And so this is back and forth, and they just say, work a little bit more this code, and then we can merge it. And in the end, it can be merged. We are nearing the end of the presentation. Another thing that is useful in GitHub and that I'm going to show you on another of my projects are called issues. And issues are for everybody to see. And they allow just to say, this is a problem or a feature that I want to do or something. So for example, okay, so this is all French as you wanted. I said, so this is an issue number 48. The pull request numbers and issues are the same. And they're incremental. So you can just do hashtag an issue or a pull request, and it will automatically know which one it is. You can, for example, do in a commit, you can do like in the bottom, close and the number of the issue, like close hashtag 48, for example, and GitHub will automatically close the issue. So it's really useful.
copy.
Yeah, or fix, or you can, yeah. Yeah. So for example, on this one, so it's me on my own project. So this is quite pathetic, but I said, you have to document the code. It's a reminder, like for me to know what I'm doing. I thought about it at one point, and made some comments, but for multiple people, like for example, for NumPy, I have 2,000 issues. I can sort them like by the most commented. So there is one that has 105. Yeah, this one is famous. So someone like 5 years ago said, okay, I have this problem with NumPy. And then a lot of people commented on that and the co-contributors. And one day this will be solved or not. Okay, and that's more or less all. You can do also projects which with like very useful because it groups issues in a Kanban style. So this is like, this is to do. You can move them to like in progress or even close them. So it's really useful if you have a bigger project or work between different people. People can just, you can assign an issue to someone and say, okay, you're going to do a graphical user interface, and you can like report on the progress and everything.
Interesting things to show maybe how to create a personal access token when you want to.
No, I'm going to show you that to authenticate, especially in private repositories, you might want to add some tokens to your. I won't show you that, but I want to show you where to learn it. So you just go to the GitHub documentations, and there you can find a lot of things. Like for example, how to authenticate. So authenticate on your local machine, push your code to private repositories. You have also like continuous integration with GitHub Actions. A lot of things. So how does it work? So for example, what I just shared to you, project management, GitHub issues. You have an overview, which is quite cool, and a lot of resources on how to use GitHub, how to use Git. Do you have anything to add? I don't see much to add. So GitHub is really the place where you, even if you're working in your repository on your own, it's a place to just gather what has been done yet. You can show the different branches and work with other people quite easily.
It's an efficiently way to collaborate.
Yeah.
So basically, you can use it on your own to keep track, to save your code, to keep track, because you all have this tool of project management, but also when you work with other people, it's easier to share the code. You don't have emails or SQL, stuff like that. You just have centralized things to share. And all these tools are easier to have keep track and be able to do things more easily. And yeah, because when we still all that stuff more local, when you use it and contribute, well, we are use various forks and stuff like that.
Yeah, definitely. Do you have any questions for this last part? No. So maybe I'm going to wrap it up because it's very late.
One question. Let's think about data for a second. You're putting data out. Is there a limitation to the file size?
Yeah, there is. So Git has things called Git large files, where you can put large files, and then at one point, GitHub will make you pay. Maybe not for the Harvard GitHub, but the standard person GitHub will make you pay. But yeah, for data, I don't know if it's like images of experiences or something like that. It can be better to just put it on the Harvard Drive and just share it that way. You can put it on GitHub, but it will also increase the size of the .git folder because it will store it like twice. So it's not really recommended to do that. You would like just send it on message drive or USB stick.
Any other questions?
I'm just going to wrap it up quickly. So Git is the recommended way to use a version control system to store the changes you made and really help you have a workflow to remove all the just work on one file and store the file history, and it will maybe help you code a bit better because you don't have to. You can just have one function and work on it and just not copy a function to have all the new things. So it's much better for you, for your project management, by also doing branches. And GitHub allows you to leverage the power of GitHub, of Git, to work with other people quite easily. So I hope this talk has been interesting. Thank you to Giovanni, who is maybe still over there, who did the slides. Thank you to Eder, who's going to Florent. So yeah, thank you to all of you.